One of the easiest ways to create a rational function that has some meaning attached to it is to start off with a familiar equation: distance equals rate times time. D equals R times T. This is the familiar equation that tells you if you're going at a rate of 100 miles per hour and you don't get a speeding ticket and you go at that rate for 2 hours, then the distance you've traveled is 200 miles. So to create one of the simplest rational functions you'll ever see, let's go ahead and make D equal to 100, let's say 100 miles. And to create our rational function, we could either divide both sides by R or we could divide both sides by T. I'm going to go ahead and divide both sides by R. So if I divide both sides by R, I'll get T is equal to 100 over R. I'm going to turn that around. T, I can call that T of R, function notation, is equal to 100 divided by R. And I'm going to call that my rational function. And I'm going to graph this thing to see what it looks like. So this is Desmos. I'm going to type in our equation, except I can't use T. I have to use Y equals 100. And then you can make the input variable anything you want, R. And you don't see much in this graph over here unless you zoom out. And then you see the graph of our function. Remember, Y stands for T, the time it takes to travel 100 miles at a certain speed, R. And so I don't think this portion of the graph that's over here in the third quadrant is going to be very helpful, because R is going to be negative, and then the input's negative, and the output time is negative. So we're not going to look at that part of the graph for our example here. We're going to look at the part of the graph that's in the first quadrant. So let's talk about what this graph tells us practically. It tells us that if R increases, okay, R is the input. So if the input values on the horizontal axis increase, then the output values, time, the time it takes to go 100 miles, will decrease. Pretty intuitive, you knew that. If you go faster, it's going to take a shorter amount of time to get to a certain place. But notice that this graph will never cross the horizontal axis, because it's always going to take, no matter how fast you go, it's always going to take some time to get to a certain place that's 100 miles away. So we call the horizontal axis an asymptote, a horizontal asymptote. And in this case, it's a line that the graph will get closer and closer to as the input R gets bigger, but it won't ever get there. It'll get lower and lower and lower in height. The graph in blue will get lower and lower, but never actually get to a height of 0. And that should make sense. Likewise, the graph will never ever get to the vertical axis. First of all, we're not allowed to plug in R equals 0, which would put you on the vertical axis. You'd get division by 0 there. And if you made R smaller and smaller, so made your speed, R stands for speed, smaller and smaller and smaller, the time it would take to go 100 miles would go up and up and up and up and up, but the graph would never cross the vertical axis. So the vertical axis is also what we call an asymptote. Again, think of the asymptote as a line that the graph will get closer and closer and closer to. In this case, as the input R gets closer to 0 from the right-hand direction, from positive values, but it'll never actually, the graph in blue will never actually touch that y-axis.